In this video, we want to design functions that meet certain criteria. In this first example, you want to find constants a and b so that the function f of x equals ax squared plus bx has a critical point at x equals 1 with critical value minus 2. So we have two criteria here. We want the critical point to be at x equals 1, and we want the critical value to be minus 2. So we have two conditions, and we want to determine a and b with those two conditions. So let's look at the first condition, critical point at x equals 1. So to have a critical point at x equals 1, we want the derivative at 1 to be 0. So let's look at f prime of x. That's going to be 2 times ax plus b. And we want that to be 0 at x equals 1. But f prime of 1 by our formula is 2 times a, x equals 1, plus b. So what I have is 0 equals 2a plus b. The second piece of information says the critical value has to be minus 2. So at x equals 1, if I plug in 1, I want that to be equal to minus 2. On the other hand, f of 1 is equal to a times 1 squared, which is a, plus b times 1, which is b. So I have a second equation which says minus 2 is equal to a plus b. I could, for example, solve this equation for a by subtracting b from both sides. I get minus 2 minus b, so a is equal to minus 2 minus b, and substitute that into the other equation to get 0 equals 2 times, and then a is minus 2 minus b plus b, and then I can solve this for b. So if I solve this for b, I get minus 4 minus 2b plus b, which is simplifies as minus 4 minus b, which will tell me that b has to be equal to minus 4. Okay, so if b is minus 4, I get a is equal to minus 2 minus a minus 4, which is equal to 2. So my solution is a equals 2, b equals minus 4. Okay, let's see another example. Find a polynomial of the form f of x equals x cubed plus ax squared plus bx plus c so that f of 0 is 1, x equals 2 is a local minimum, and x equals minus 1 is a local maximum. So in this problem, we also want to find a, b, and now c. We look again at the conditions, and we use them to find conditions on a, b, and c. So what does f of 0 equals 1 mean? Well, on the one hand, I want f of 0 to be 1. And on the other hand, I know that when I plug in 0 into this function, well, 0 cubed is 0, 0 squared is 0, b times 0 is 0, and so all I get out is c. So this first condition tells me that c is equal to 1. Let's look at the second condition. X equals 2 is a local minimum. Well, that tells me it's a critical point, and so therefore I expect the derivative should be 0. So now let's look at the derivative. F prime of x is equal to 3x squared plus 2ax plus b. And the derivative of c is 0 because it's a constant. So I want f prime at 2 to be 0 so that I get a critical point. Now if I plug in 2 into the derivative, I get 3 times 2 squared, which is 4, plus 2a times 2 plus b. Or in other words, that's the same as 12 plus 4a plus b. So one equation I get is 0 equals 12 plus 4a plus b. That comes from x equals 2 as a local minimum. X equals minus 1 is supposed to be a local max, meaning that the derivative should be 0. So again, I'm going to look at f prime, but now at minus 1. If f prime minus 1, if I plug in minus 1 into my derivative, I get minus 1 squared is 1, so I get 3 plus minus 1 in for x here gives me a minus 2a plus b, and that should be equal to 0. So I get a second equation, which is 0 is equal to 3 minus 2a plus b. These are my two equations. One way to solve this is to subtract one from the other, thus canceling the b. So 0 from 0 is 0. 3 from 12 is 9. Minus 2a subtracted from 4a is 6a. And then b from b is 0. Okay, so that tells me, now I can put the 9 on the other side, I get minus 9 is equal to 6a. So that means a is equal to minus 9/6, which is the same as minus 3/2. And then for b, I can use a to substitute in to find out what b is. So b is going to be equal to, from the say the first equation, is going to be equal to minus 12 minus a 4a. So that's minus 12 minus 4, and a is minus 3/2. So that's equal to minus 12 plus, and then I have 4 divided by 2 is 2, so that's plus 6. Minus 4 times minus 3/2 is plus 6. So that gives me a minus 6. So that's b. So altogether, a is minus 3/2, and b is equal to minus 6.